Do you know what will happen if you read?
My emotional wound. I choose to heal my negative belief. I choose to open my heart to myself. I choose to open up my mind. I choose to believe in myself. I choose to feel the power inside of me. I choose to change my energy. I choose to embrace all the wounds and scars. I choose to embrace all haters. I choose to embrace my defensive self. I choose to be free. I choose to love myself. I choose to trust myself. I choose to respect myself. I am free. I am love. I am joy. I am powerful. I have power to change my life. I have abundant love to share with others. I love myself. I trust myself. I respect myself. I allow myself to feel my body. I allow myself to feel my breath.
What secret did the richest man in the world share with
Now book professional home painting service.
I allow myself to feel my body. I allow myself to feel my breath. I allow myself to feel my feelings inside. I allow myself to feel any discomfort and pain. I allow myself to focus on healing. I allow myself to breathe through the pain. I allow myself to let go of self-doubt. I allow myself to let go of worries. I allow myself to let go of sadness. The pain. I allow myself to let go of self-doubt. I allow myself to let go of worries. I allow myself to let go of sadness. I allow myself to let go of judgment. I allow myself to let go of self-criticism. I allow myself to let go of negative belief. I allow myself to let go of anger. I allow myself to let go of anxiety. I allow myself to let go of attachment. I allow myself to let go of fear. I allow myself to bring positive energy. I allow myself to bring bright energy. I allow myself to bring warm energy. I allow myself to bring healing energy. I allow myself to gather my mind and focus. I allow myself to heal my body. I allow myself to heal my emotional feelings. I allow myself to heal my negative belief. I choose to heal my body. I choose to heal my emotional wound. I choose to heal my negative belief. I choose to open my heart to myself. I choose to open up my mind. I choose to believe in myself. I choose to feel the power inside of me. I choose to change my energy. I choose to embrace all the wounds and scars. I choose to embrace all haters. I choose to embrace my defensive self. I choose to be free. I choose to love myself. I choose to trust myself. I choose to respect myself. I am free. I am love. I am joy. I am powerful. I have power to change my life. I have abundant love to share with others. I love myself. I trust myself. I respect myself. myself to feel my body. I allow myself to feel my breath. I allow myself to feel my feelings inside. I allow myself to feel any discomfort and pain. I allow myself to focus on healing. I allow myself to breathe through the pain. I allow myself to let go of self-doubt. I allow myself to let go of worries. I allow myself to let go of sadness. I allow myself to let go of judgment. I allow myself to let go of self-criticism. I allow myself to let go of negative belief. I allow myself to let go of anger. I allow myself to let go of anxiety. I allow myself to let go of attachment. I allow myself to let go of fear. I allow myself to bring positive energy. I allow myself to bring bright energy. I allow myself to bring warm energy. I allow myself to bring healing energy. I allow myself to gather my mind and focus. I allow myself to heal my body. I allow myself to heal my emotional feelings.
Hi everyone. Very good evening. First of all, let me know if you are able to hear me properly, clearly. Do give me a yes or no on the chat box.
Yes, we can hear you.
Thanks, Reyansh. So, first of all, I would like to welcome you all to our session. So, welcome again to the third session on data analysis using Python. We'll be proceeding ahead with our today's agenda. But before that, does anybody has any questions, any clarifications, or anything they would want to talk about before we get started, or they would want to talk about something that was already covered in our previous sessions, something like that, anything of that sort? Please come up, unmute yourself, or mention on the chat box, so that we are ensuring that everybody is aligned, everybody is able to absorb, and we are able to proceed ahead in the right manner. Kindly come forward if anybody wants to speak up about anything, or if there is anything that you may want to revise or discuss upon, that would be a good opportunity to do so.
Hi, Prashant.
Hi. Go ahead.
So, Gnaneshwar here. First of all,
Go ahead,
thank you
Ganesh.
for the last session. Yeah, so I just went to the recording today, and it was really a hands-on session. Though could not get the time to do the practice of all the things that you shared. I just have one
Problem.
question that in the Anaconda, in the Jupyter lab, when
Right.
we are writing the code, generally, so Anaconda being the IDE, I was wondering that when I say, suppose I make import pandas as PD, and then I say PD.read CSV or read Excel. So on the dot, generally the IDE gives the autocomplete functionality, but I was not able to do that here, and which takes a time then to kind of type everything. So is there, how can we do achieve that autocomplete functionality? That was my question actually. If you can please help me with. Yeah.
Okay, so you are facing some challenges executing the code on Jupyter Lab. Is that what you were trying to convey?
No, I am able to do the coding. The only thing is in Java, if I say system in IDE, then system dot, if we do, then it builds the out and dot println automatically. In the same way here, when we say data frame or when pandas library, we try to access different functions. Then after the dot, the list of the functions automatically comes, right? But here I am not getting that list, so I have to manually type all the things. So that is taking little
I
time.
understand. I understand that.
Yeah.
So basically, a Jupyter Lab is not a code editor actually. So that functionality is there in multiple IDEs, which also provide code editing functionality. So like we have Visual
Okay.
Code Editor, Visual Studio Code Editor from Microsoft, and then we have Eclipse,
Okay.
which is a very well-known IDE. So such kind of
Right.
IDEs provide coding editors as well inside. So when you try to write a code, it basically gives you suggestions to autofill that code. What all potential functions that you could be trying to write off. So those give you suggestions. But since Jupyter Notebook is not exactly a code editor, it gives you a functionality to basically compatibly execute your code or in a parallel way to ensure that you are able to validate all your pieces of code in a serial manner. So that is the purpose of Jupyter. It is not exactly a code editor, but if you want to leverage that functionality, I would request you to either use Microsoft's Visual Studio Code Editor. There, if you set up the environment for Python and all that, it would give you recommendations like you're expecting. But since that is not something a functionality of Jupyter Lab, So that might not suggest those suggestions as of now.
Okay, Prashant. Thank you for this clarification. So if I understand it correctly, if I want to continue coding in Jupyter Lab, then I'll need to kind of remember the function names and manually type them, kind of thing, right?
Yeah, sort of. So you will have to
Okay.
somehow keep, like, you have to remember what kind of functions are using, or you can copy your code by writing into some kind of code editor. Let's say Notepad++ is also one very good code editor that you can use for such cases. So you can copy your code from any code editor and then put it on the Jupyter Labs. So that is how also you can do.
Yeah, this makes more sense. Yeah, perfect. So I can use even Notepad++ is easiest way to do it, and then I can copy paste it into the lab. Yes, perfect.
Right.
Yeah, thank you.
But thanks for coming.
Things you can load as well. I'm just posting a link. I haven't tried it as such, but I was just searching for it as well. So as Prashant was saying, it depends on the ID as well. So if you're using Visual Studio, it does allow it. If you want to try it in Anaconda, I haven't used it, but it may be worth trying this Hinterland plugin extension, so you can have the IntelliSense capability.
Sure. Thank you, Dr. Mukesh, for this. Yeah.
So thanks, Ganeshwar, for coming forward. Anybody else wants to speak about anything else? Do come forward if anybody wants to speak about around anything. Otherwise, we can get started. Okay, I seem silence means no. So let's get started with our today's session. So I had shared the data set on our WhatsApp group yesterday. Apologies, I delayed it. But then I had asked some of you to basically come up with potential questions or insights that we could target. So has anybody, I see some of the questions were posted. Thanks for that. But we'll get started with today's session and we'll look at some more potential insights that could be gained out of the data set. So I will share my screen. Just let me know once you are able to see my screen. Let me know if you are able to see my screen. So I might not be able to access the chat box now. So yeah, you can either give me an acknowledgement, or if you can also put on chat, but I think that will be notified me. Yeah, okay. Thanks for confirming, Rian. So let's do a quick recap. So on our day first, session 1, we saw how matplotlib can be helpful in visualizing data. So we tested around a couple of examples like these, and we tested how we could build basic graphs and add some content to our graph, edit around using the graphical functions, graphical methods available in matplotlib. So this was with respect to matplotlib that we explore around on our session 1. And in our session 2, we basically focused on using pandas and tabular data, and every tabular data in pandas is called a data frame, which is a two-dimensional data, and if it is only a single-dimensional data, which is only into single dimension, it is known as series. So we explored a couple of, we did some experimentation around pandas functions. We had our desert data set, which had Olympics data of last 100 years. So we tried to figure out some of the important insights that we could pull out from those that huge data set, which had millions of rows, which had more than 2 lakhs of rows. So we tried to figure out data like which were the eldest players who participated, and then which were the youngest players which participated, and then we pulled out the sorted data. Then we identified countries, we identified how many medals had been distributed, which were the top country which had won the most of the medals, and which were the top 5 countries which won the top medals, top gold medals. We also tried to do some visualization for the medal count of those countries. So we explored, then we further specifically focused on the trends, Olympic trends for India. What are the number of gold medals which have been won by India? What are the events, sport events in which India has won medals? And then which players helped India won medals in which years? So we tried to analyze a whole lot of data through our data analysis Python programming. So anybody has any questions around this? So today we are gonna focus more on other insights that we could not target in our previous session. But if you have any specific queries, please feel free to ask. Okay, seems everybody is very much clear with all the concepts, so that is really good to know. So today we'll start like with Dr. Mukesh. So he would like to explain certain things initially during the session, some core concepts and some good things that will make you have a good understanding about a lot many data analysis concepts. So Dr. Mukesh, would you want to start?
Yes, thanks, Prashant. Let me share my screen. I want to share with you a slide
Sure.
which will make it in a visual. Just give me 1 second. Screen.
Yes.
And you can hear me.
Yes, we are able to see your screen, sir.
Okay. What I wanted to cover today was the big picture. So when we say we are doing data analysis, we've talked in the few sessions, where does this data come from? But I wanted to put a visual because in IT, breadth is more important than depth. If you want to career your progression, IT career is more rewarding financially if you know little bit about everything instead of knowing everything about one thing. So the more exposure do you have to all these little things, you're rewarded financially, and your job title will be more not just a data analyst, but you may want to pursue the path of a data architect as well. So you need to know a little bit about everything. So having that big picture gives you a better perspective and a view of what it is, that's something that you're doing. So in this case, we are doing data analysis, but in the big picture, where does data analysis fit in? We want to cover that today. So it's a little theoretical, but it's important theory to understand because it will make sense. So the way it works is, we in an organization, there are a lot of different types of data sources. So we are analyzing data, but where does this data come from? Where is this data stored? And how is this data analyzed and consumed? We want to understand the life cycle of data. So we'll start from the extreme side and see what are the data sources. So those data sources can typically be divided into three categories. One is your internal data sources. So within your organization, you have multiple lines of businesses, or you might have one business. Let's take a retail company. So in your retail company, you've got your grocery division, you've got your retail articles that you're selling. So grocery is separate from retail, but it's still part of the same store. So you can have one line of business, which is groceries, one line of business, which is retail products. Like you might be selling toys, you might be selling books, and so on. So if you go in a supermarket, there are different sections. There's a catering section as well. So each of those is a line of business. Or if you're going in a bank, the bank is doing retail banking where you can not only deposit your cash and everything, but you have a mortgage department. So that department is a line of business because you're applying for a mortgage. Similarly, in insurance, you are applying for insurance. You could be applying for car insurance. That is one line of business. You could be applying for home insurance. That could be another line of business. Corresponding to each line of business, you'll have backend IT systems which are capturing those transactions. So I apply for car insurance. I have an application which collects my information about the car. It collects information about who I am, and it stores those details in some backend IT system. So that system, an IT system, has its own front end. It might have its own portal UI in which we allow the end user, the customer, or the member to enter information about themselves and about that insurance product. They hit the submit button. That information is captured from that screen and is stored in some database. So one IT system will provide you that functionality to capture all that transactional details. And then you may have subsequent details. You may want to file a claim. So you may go in the profile and say submit claim, and it will store all that information in the transactional system. Similarly, you might have a backend application which is collecting all that mortgage information and storing it in that backend system. Most of these IT systems, they'll have a front end where you have a portal where you're capturing all the information, and it will use some API and it will submit that information to some database. But there would be some third-party software which you're installing on your on-premise data center servers, or you may using software as a service application. But essentially behind the scenes, it has a front tier, a presentation tier, which captures the information from the user, some integration tier, which takes that information from the user and puts it into the database. So that's what an IT system is. So you may have multiple IT systems in an organization, very typical. The way the IT industry has evolved is we tend to buy software instead of building our own. So early in the 2000s, Java was the default language. Then .NET came in 2001, and now you had the question of, I want to build my own IT system. Should I do it in .NET versus Java? And then more and more software started coming up. So if I want to manage my employees, previously I would just write code and build my own application. But now you've got software companies which sell HR management software. You have companies which sell finance software. So you do all the accounting and everything. So you don't write your code to do that because it's a lot cheaper that way. So now instead of writing our code and building our own system, we do a search and see what software to buy, or now instead of buying, renting it as well to provide that backend capability. So that becomes your IT data sources. So many times, you'll have a HR backend system or a human capital management system. If you are in the insurance industry, you'll have a claim adjudication system. The most common one in retail or anything which uses supply chain. So retail, you have a warehouse, and then you are sending that warehouse to the store, and then you have an online portal for shopping as well. So all that comes under the category of ERP, Enterprise Resource Planning. So if you hear the word SAP, Oracle E-Business Suite, Lawson ERP, different kinds of companies selling that capability called ERP. So if you're in the retail domain, you should know what is ERP. When I say you should know what is ERP, even high level enough, you need to be able to talk about it for 2 to 5 minutes to clear the interview. Rest you can learn on the job, and plenty of YouTube videos to explain what is ERP. So you'll have a finance system, you'll have a customer management, and so on. I've just listed some of it as well. But essentially, there are multiple backend IT systems, some on-prem, some we could be renting it on the internet as a software as a service application. Salesforce, we conducted Salesforce trainings a few months back. Salesforce is an example of CRM, customer relationship management, where you're storing all the interaction about the customer in that system. How is it and why is it related with data analysis? All this data which is captured into these IT systems, we want to bring this data out of the IT systems and consolidate this data onto a common platform. That is the most common data strategy that organizations use. And that strategy is consolidation. There are two strategies. One is you either consolidate your data from multiple IT systems on one common data storage platform, such as the data lake, or you virtualize the data, but it's preferred to consolidate the data. Next question, why do we want to consolidate the data? Why can't we use the data within the transactional system? Why should we consolidate it outside that IT system onto a common platform? And there are primarily two key reasons for it. And this may be an interview question as well. Why do you want to bring this data outside the transactional system onto the data lake? Two reasons. One is if you do all this reporting and analytics, whether it is descriptive, like what happened, how many customers did I enroll, or how many customers should I be enrolling, or I could be enrolling, or what type of customers should I enroll, that would be prescriptive. If I want to do that analysis on the transactional system, a lot of these IT systems, they will provide you reports to do operational reporting. Operational reporting, simple way to remember it is an operation theater. What does an doctor do in the operation theater? He's focusing on this, what needs to be done now. The doctor in the operation theater is not going to study and tell the patient, why did you smoke so much that I have to do a lung operation? No, he's focusing on what needs to be done now, right? He's focusing on what happened 2 weeks back, so he's able to do the surgery, right? He's not doing all that analysis. Why did the person smoke and all that? That is not important. What happened in the past, so he can do the surgery now. Is his blood pressure okay? Everything okay? So operational details. So similarly, operational reporting, did my customers get all the products that they were trying to purchase? How many mortgage applications did I process in last 2 weeks or in last quarter? That is all operational reporting or descriptive reporting, focusing on what happened recently, what happened in the past, but the past is more recent. So although most of the tools do offer, may or may not sometimes offer operational reporting, usually the trend is to pull that data outside that IT system and do that reporting outside the IT system, because you don't want to impact the performance of the IT system. Why operational reporting would impact the performance of the IT system? Because anytime you're doing reporting, it is running a query on your data in the backend system. Every time you run query on the backend system, it's consuming some CPU cycles. If you do more and more reporting throughout the day, ultimately it starts impacting system performance, because you are doing other things than what this transactional system was doing, which is doing transactional data. What is a transaction? Customer submits that submit button. That information goes from the front end portal UI onto that database. You're retrieving information. Your IT system's core capabilities to perform some transaction, some operation. So if you're doing other things like reporting on it, you need to add more infrastructure and capacity. Every time you add more infrastructure and capacity, your licensing cost will be impacted, because now you need more hardware. If it's software as a service, sometimes you have these governance limits on what you can do, whether it's AWS or Salesforce. So there are limits on what you can do. So you may want to pull the data outside of that IT system, so you don't either hit those limits if it's a SaaS, software as a service capability, or you don't unnecessarily want to add the infrastructure and have additional higher licensing cost, because your licensing cost is based on how many servers are you using, how many CPU cores you're using. That's one reason. Second reason is Many times you want to join the data across these multiple IT systems. So I not only want to know how many mortgage applications I processed, I want to create a 360-degree view of my customer. I want to know what is this customer done, what kind of business this customer has done with me. Did they apply for a mortgage? Did they make any deposits? Did they do any online shopping, which I send them as a voucher code? Did my customer buy any insurance product from the bank as such? I want to know everything that the customer did. So if it's a high valued customer, I can give them more offers, or I can tell them what in something in the past, but they are not doing it. I can bias them or prompt them to do something. In order to do that, there is a need to join the data across multiple IT systems. If that data is logged within that IT system, then joining is I have to use a virtualization software product like Denodo, or I bring the data outside of that IT system using a CSV file. I can export that data as a CSV file. Then I can analyze the data by joining it in Notebook, and I can start answering questions. What type of business is this customer doing with this organization? So if I want to do that analysis of the data, I have to join the data where each system is exporting that data onto this platform. The most common platform is Data Lake. In the past, what we did was we used to bring this data out of the IT system for operational reporting. We would publish this data onto another platform called Operational Data Store, ODS. So operational data store would have a replica of this data in real time, or you would use an enterprise service bus to push this data out of this IT system onto another server, another database, and we call that as a system, and we give the name operational data store. In simple words, it's a data store or a database where you can bring in data in near real time from that IT system, so you can do operational reporting of it, because that solves one of the two problems where I don't want to impact system performance. So I got data out of the IT system and I put it in the operational data store. Problem solved. I don't have to, I'm still providing additional infrastructure because I put a provision for a server on that ODS, but I didn't have to pay the licensing cost. I can do my reporting and define my own reports and create those reports using Power BI or Tableau, pointing to that database in that operational data store. So ODS solved one problem, but that is only operational report. I want historical reporting or analytics as well. What is happening to my customer in the past 5 years? What is my percentage growth of customers in the past 5 years? So we derive insights from information, and information we gather from data. So what my customer purchased is data. They purchased $200 worth of goods. That is a data point. Information is that my customer has been consistently purchasing products in the last 1 year, and the average cost of the purchase is $100. That is information which I gathered by analyzing those data points. Insights could be that given the trend that my customers be purchasing $100 worth of products in the past 5 years, and the inflation is going up, the next year the customer could be purchasing $120 worth of product, and I could even predict what type of purchases the customer can make. That comes all under the part of data analysis. So now I have an ODS. I need another store which I can do predictive analytics, and I can be able to do all this prescriptive analysis as well. Now, if I do all this under the operational data store, I have to add more capacity, and the purpose of operational data store was more operation, what happened in 3 months, and not what happened in the last 5 years. What difference does it make? This is the granularity of the data. When I need to know what happened in the 3 months, I need to have all the detailed attributes of the data to know where the customer purchased what. Did they purchase it in the store? Did they purchase it online? Did they purchase, which state did they make that purchase? I will store all those details because my backend transactional is capturing that data. One of the other advantages pulling the data out of the transactional system and improving the system performance is I don't need to store all this data for the past 5 years and 10 years in the transactional system. Because if my transactional system is doing reads and writes, for it to be highly performant, every time it's inserting a record in 10 years worth of data, let's say in 10 terabytes, and if I'm doing a read, even though I'm doing indexing, I'm searching for that one record in 10 years worth of record. But I don't need to if I'm just keeping last 2 years of record. If I need that 5 years of record, and primarily I need it only for analytics purpose, let's bring that 5 years data out of the transactional system on some other platform. That way my transactional system doesn't not only need more additional hardware, it will perform better because it's not needing to know all the last 10 years of data. It can work perfectly in last 2 years. If my customer submitted an application in last 2 years for a mortgage, I can retrieve all that information. Other than that, I'll archive it or store it in the data lake. So summary is we need to bring data out of the transactional system. We need to put on a consolidator platform. In the past, we put it in an ODS, but ODS doesn't do predictive analytics. So we needed something else which did predictive analytics or which did it more historical analytics. So we had another system called a data warehouse, where data warehouse is doing the aggregation. In the operational report, I had more details of the data. Where did this person make the purchase? Did they make the purchase online or did they make the purchase in the store? I had more detailed data to be able to answer that. But when I'm just collecting the information, how much is the average value that the person made? I may not need that data, whether they made the purchase online or whether they made it in the store. I just need to know what was the purchase amount. So I can store the aggregated value per quarter instead of storing it what is the purchase made every day. So I have to store less data, and you would do all this aggregation and calculations in a data warehouse. But these data warehouses, licensing cost was expensive. Example, and this data warehousing was done on-prem. Example of data warehouses were Teradata and Netezza. And you can use Oracle database as well. Netezza is a hardware appliance by IBM. Teradata, you build these specialized high-end servers, very expensive. And you would do your data warehousing over there. That was in the past. So IT system, publish your data using some integration tool. You can either replicate the data using some data replication software like Oracle Golden Gate, or you can move the data every hour in a micro batch using ETL tool, or you can use change data capture. As and when a change occurs in the transactional system, you publish that change to the ODS. ODS will do operational reporting. And then from operational reporting, you send another historical batch. Every day you send a batch to the data warehouse. Your data warehouse would do analytical reporting. That's what happened till the early 2010. That was the most common pattern. So if you're an organization, they'll still probably have an ODS. They'll still probably have data warehouse because that's what we did in the past. What changed was the data lake. So in one of the sessions, we covered what is a data lake and the advent of big data. So these data warehouses, they were very expensive. They did limited or no predictive analytics. You can still do limited predictive analytics, but nothing using Python. And you would always only bring relational structured data. If you wanted to bring in streaming data, social media analytics, and so on, that's all JSON. So they weren't meant and designed for it as well. So there was a need to consolidate all data, operational data, historical, analytical data. There was a need to consolidate all different types of data, structured data, which is in a relational database, semi-structured data like JSON and XML, and unstructured data, such as images, videos, text in an email, or any textual data as well. You can store all of that data on this platform, which we call as a data lake, which underlying behind the scenes, it's nothing but you can store it in an object storage, or if you're using AWS, you can store it in Azure Blob, or if you're using AWS, you can store it in an S3 bucket. If you're using GCP, you can store it in GCP bucket. But you essentially dump all the data. Instead of sending it to ODS and data warehouse, taking that route, in the modern day world, you bring in the data from the transactional system and you put it on the data lake object storage in an Azure Blob or an AWS S3 bucket or a GCP bucket, and you store the data as it is from the transactional system. You don't pick and choose, oh, I'm going to give this attribute because I want to save on the disk space. To save on that disk space, we used to do this aggregation of the data and store the limited attributes of the data, and we used to change the granularity. Where the customer made the purchase, in which store, that is granular data. How much the percentage of the purchase was made in which store, now it doesn't matter which customer made that purchase, right? I'm abstracting it, I'm aggregating it. So it was okay to lose data, but storing an aggregated value of the data because data storage was expensive. Not anymore. This cost of data storage has drastically, significantly gone down. So data storage, data duplication is not a consideration when designing IT systems. We don't want to throw away any data because that data might have some information which we could derive, and from that information we could potentially derive insight. Instead of going that route of ODS and data warehouse, you bring in the data from the IT system directly into the object storage on the data lake. That is the trend. And now you can not only bring in data from your internal line of business sources, you can bring in external data source. If you're a retail company, you want to know what impact weather has on what products are you selling. So if it's hot weather, you're probably going to, sell more cold drinks. You're going to sell mangoes, right? If it's cold weather, you're going to sell more hot drinks. So weather has an impact on our mood and our purchases. So what the customer is going to buy and shop is going to be different. You're going to buy a more shorts and t-shirt in summer, whereas in winter, you would want full sleeves. So the type of purchases and everything, weather has an impact on the shopping behaviors. So you may want to bring in data from external sources like weather.com. There are companies like Nielsen which will send you competitor data. You can buy those competitor data saying how much is the average price of grocery, or what is the average price of milk in a particular pin code or a zip code. You can get that competitor data from third-party companies like Nielsen in the retail domain, and you can bring in that data as well. You always want to do social media analytics as well. Social media analytics, people are continuously posting on Twitter or X now. They're continuously posting on Meta, Facebook, Instagram, and so on. You want to analyze that and say, which of my customers are not happy with me and they're posting bad press about me. So you want to do customer sentiment analysis. That's one of the common use cases for data analysis as well, which is knowing what is the sentiment of my customer. Is my customer happy? Is my customer just satisfied? Or is my customer not satisfied and angry with me? You want to respond to those not happy, angry customers, because if you don't respond to them, they'll keep on publishing and saying, this company is bad, they did this, did that. But if they hear from you, then they are more calmed down. So you want to respond in time. So the timely response is important. If someone says something bad to you and you say sorry right away, they'll be fine. But if you tell them sorry after 2 months, that sorry doesn't matter. Similarly, if a customer is angry, you're responding to their social media post after 2 months, that response is irrelevant because you've lost that essence of time. So the timely response is more important than the actual response, which means when you are collecting all this data, you want to process this data in a timely fashion. If you do it in a batch mode and if you process it even after 1 day, it may not be relevant. The damage is already done. So you want to reduce the data latency when you are processing the data. So you have different data integration tools to bring in data from all the different data sources and publish it over here, right? I'll take a pause over here. Any questions so far? Because it's a lot of information, so I'm sure it takes time to grasp it, but want to make sure you're all with me on what I've covered so far.
Mukesh, can I say something?
Yes, please.
Yeah, so yes, as you rightly said that it's a little overwhelming for sure, but just trying to summarize the understanding so that you can correct. So we started with this bigger picture of when we talk about data analysis, but what exactly is the bigger picture? So we started with the data sources, and you talked about some internal data sources, and these internal data sources come to the IT systems, and IT systems then send this data coming from the different sources to the backend systems. And that backend system, you initially explained about the operational data store, wherein the data gets stored, but it does not have the capability of doing a lot of historic data analysis. So then you talked about data warehouse, the second option, where the aggregation and calculations can be done, and it's on premise and very heavily expensive. And then I guess to mitigate that, you talked about the data lakes, wherein we can have all the types of data, means operational data, historical data, analytical data, structured data, even the data coming from the streaming sources, different streaming sources. And then we can have that data lake kind of a platform for that. This is what I tried to
Perfect.
infer
Perfect.
so
Perfect.
far.
No, you
So
summarized it extremely well, and you'll have the recording as well, because this information will make you more confident, and you'll get used to the buzzwords. But you summarize it extremely well. Thank you for doing that. Yeah. So old style of the data was the data pipeline was you move the data from the IT system, and that IT system, that data, the IT system has multiple servers in it, which comprise together as an IT system. It has one server for the front end. It has one server which is exposing those APIs, and then one server which has the backend database. And then from that database, in the old way, you would bring that data to ODS, then from ODS to data warehouse. The new way, you bring the data from the transactional backend system, from the database into the data lake. So very well said. Any other
thank you.
questions over? I have the rest half part to cover now, but I want to make sure you're all following till here. And if it's overwhelming, don't worry, you'll have the recording. You can ask me questions next week as well, but I want to make sure you understand where all this data is coming from. Why are we putting it into the data lake? Why are we consolidating it on the data lake? Because we want to join this data, right? And we want to do predictive analytics. We want to derive insights from this data. Okay. So how do we bring this data to the data lake? There are different ways you can do it. The most common way is change data capture. Why change data capture is the most common way? Because it helps you minimize the data latency. Data latency, in simple words, means the data lag between the time at which this information was created and the time by which it got over here. If I have a batch field, right? If I have a batch process and I'm doing this in batch, I'm saying I'll bring in data from this backend database belonging to an IT system, and I use an ETL tool. Like ETL tool example would be Informatica Power Systems, right? Most common ETL tool. You could be using Talent. If you're on the cloud, you would be using AWS Data Glue. If you're on Azure, you'll be using Azure Data Factory. Many times they use a lot of these buzzwords. You're using a data fabric which could be a collection of multiple tools which allow you and make it easier for you to ingest data, right? Just like how we digest food, we ingest data from multiple data sources onto the data lake. So you can be using any of these tools. Most common is use a change data capture tool. Most of the databases nowadays have the inbuilt native capability that as and when a change occurs, it will trigger and tell you these 10 records have changed in the last 1 minute, or these 2 records have changed in the last 1 second. It will publish those changed records, that entire row of that data, as a JSON object, and it will publish it to a messaging platform like Kafka. And then from Kafka, you bring it, you subscribe to that data on Kafka, and you bring it onto the data lake. I know I'm throwing a lot of buzzwords, but so you can ask in the subsequent question. So does everyone heard or know what is Kafka? Okay, I'm not able to see the chat window, so I'm assuming you guys know what is Kafka.
We are not aware, sir. If you can please elaborate.
Okay. So everyone should know, if you're planning a career in IT, you should know what is Kafka. You should know what is APIs. I also mentioned APIs. I'm assuming everyone knows what is an API, application programming interface. Is there anyone on the call who doesn't know what is an API? And I'll digress and I'll explain what is an API, and I'll explain what is Kafka, the concept behind Kafka. But let me even take a step back, because I'm making a lot of assumptions. So I want to make sure you are following everything. Is there anyone on the call who doesn't know what's an API? Please use the microphone, because I'm not able to see the chat window. I'm on full screen. Okay, everyone knows what's an API? Okay, good. So API is nothing but you're exposing your data as a service. It's a real-time interface through which you can query your data. You can submit data. You can perform CRUD operations. CRUD meaning create. C for CRUD is create. R is read. U is update. D is delete. So you can do create, read only, update, delete operations on your data, right? But you're doing those operations through the web using HTTP, but you're able to perform those operations from the web, right? And be able to insert that data or read that data, and that interface through which that HTTP URL that you get is an API. It's an application programming interface. It's an interface through which you are inserting or reading the data. The most common API is RESTful API or REST API, which uses HTTP protocol or HTTPS protocol to make it secure. In the past, before REST, we had SOAP, Simple Object Access Protocol, which was using submitting XML data over HTTPS. Now it's more JSON, it's more lightweight. So all your mobile apps, they're using RESTful API. So when you're clicking to that SBI Yono app, behind the scenes, the app is using REST API to connect to the banking backend IT system, right? When you're using your HSBC app, the app is using REST API to retrieve your account information from that API, which is exposed by the backend IT system. That is what an API is. When you go to Make My Trip is making API calls to multiple airlines to get the fare for you to show you the comparative fare in a tabular format. But how does it know what is the cost of the fare from Mumbai to Delhi for Air India? It's making an API call to Air India. It's making an API call to Indigo. It's making an API call to SpiceJet, which retrieves the fare from their database because SpiceJet is providing that API endpoint. Yeah, that is what an API is. Because you'll see that I have an API gateway where if I'm consolidating all my data onto this data platform, can I use it as a data hub, and I can have an API gateway which is exposing that data as a service, or I can potentially sell that data as a service to my customers. So that's one important concept. What is an API? The other concept is the concept of publish and subscribe. Right? It's always easier to remember these concepts if you can relate to them in our day-to-day activities, right? Like operational data. Remember operational data, operation theater. What's happening in very recently. Similarly, publish and subscribe. The most simplest, easiest way to remember is radio station. When you're driving and you're driving in a car, you're tuning to radio station 96.1. All the information that is being published by the radio tower, you are able to listen. You are subscribing to that channel. Whoever subscribes to that channel listens to whatever content is published on that frequency 96.1, right? I don't want I don't want to listen to that song. I'll just shut off the radio, or I'll change the frequency and I'll listen to something else. Very simple. But what is the concept? You are publishing information. Whoever wants it, you are subscribing to that information. We all know how that works. That concept is very relevant in IT and especially to data. So my customer made a mortgage application. My backend system captured that information. Using change data capture, it published that information that this customer is trying to applying for a mortgage. Whoever needs this information can subscribe to this information like a radio channel, but instead of a radio channel frequency 96.1, you have a topic. The topic could be mortgage application. Whoever wants to get information about who are the mortgage applicants, they can subscribe to that topic and get that information. So if you want to easily share information in near real time across your IT organization, you can use the publish subscribe mechanism where you're publishing data on a particular topic and you've got multiple IT systems which are consuming that data and get a copy of that information. One of the recipients of that copy of that information could be a data lake. So Kafka is the most common tool in the IT industry. Almost every company uses, where you're publishing data onto Kafka. You're subscribing, you're writing a consumer to subscribe to data to Kafka, and you get a copy of that information. So instead of me trying to write a batch job to pull data out of that database and put it onto the data lake, use change data capture to know what has changed, 3 records changed, publish them onto a Kafka broker, and then Kafka broker will publish it as that topic. You as a subscriber, you write code to say, okay, anytime anything which has the topic mortgage application, I want a copy of it. You would have a consumer which will subscribe to that Kafka broker topic, retrieve that information, write it to the data lake. That's what Kafka does. We call it as the pub sub mechanism. So this concept is very powerful, very much used in IT. So you get that capability on the cloud as well, right? So AWS also has a pub sub capability. So does Azure as well. So you have multiple capabilities. You've got Event Grid in Azure. On AWS also similar, same with GCP as well. But the capabilities pops up. Is everyone clear with the concept of how information is broadcasted and what Kafka does? Remember Kafka radio station. So the concept will become very easy. And you can explain this because they will ask you, uh, explain Kafka. It's very challenging to explain, but if you use this radio station example, they will know that you've understood the concept. The interviewer will feel confident that you've not only understood the concept, but you explain to them in an easy to understand manner. Okay. So we got this data onto this data lake, right? All types of data. Data warehouses in the past were more relational. Now they can do everything, but it's too late. By the time they could innovate and provide all that capability at a very high licensing cost, data lakes had evolved, and we moved from on-prem data lakes using Hortonworks, Cloudera, MapR, and now we are on the cloud. So it's very elastic, a lot of computing power as well. So now the question is, I got my data onto the data lake in an object storage. What do I do with my data? How do I consume the data? One of the use cases is descriptive analytics. You analyze the data using Python. So you're getting these CSV files, you're analyzing this data, right? And you're using notebooks, right, to analyze the data. But where are all these computations happening, right? So they could be happening in memory. So you're typically in an organization, the way it would work is you would write a notebook in Databricks. You would use a Databricks cluster where all this processing would occur. So you got massive computational power to do that. Yep. And then that's one use case, but you still may want to do data warehousing. The need is there, but instead of using the traditional route of ODS to on-prem data warehouse, now you've got native data warehouses. So Teradata used to be the market leader for data warehouses in the early 2000s, 2010, 15, so on. Not anymore. The most prevalent, commonly used cloud data warehouse is Snowflake. So if you want to understand what is Snowflake, just plenty of information. If you want to invest your career into data architecture, read and learn about Snowflake. Even if you just know what is Snowflake, it's a cloud data warehousing platform. Good enough. If you can talk about Snowflake for 2 to 5 minutes, you've got the job, because all organizations, they are moving away from Teradata, Netezza, they are moving to Snowflake. If you even have the keyword Snowflake on your CV, your CV will be shortlisted over other candidates because you know what's in the market, you know the entire big picture, you know exactly what's happening. So remember Snowflake. Yeah. Uh, Analytics compute engine, you want to do deep learning, you want to do more predictives, so you need analytics compute engine for it. The default, the de facto, the standard industry market leader is Databricks. Now Snowflake is trying to do what Databricks does, Databricks is trying to do what Snowflake does. So Databricks can also do data warehousing. Snowflake recently added in the last year or so, you can use Python within Snowflake to do data analysis. But if you've got the concept, what is data analysis, how to use Python to do the data analysis, whether you're doing it in Databricks using their notebooks or whether you're doing it in Snowflake, doesn't make much difference to you because it's just providing you that computational power to do those calculations on terabytes of data using terabytes of memory, if not gigabytes of memory, to do all these calculations fast. Why do you want to do fast? Because there are a lot of use cases which require timely response. If your customer is in the store and you know what they've put in your shopping basket, right, by using sensors and everything, you want to know what coupons to give them so that they will buy more. You'll tell them, if you purchase 50 rupees worth of products, you got only 35 in your basket, I'll give you ₹5. You will probably say, yeah, I'll spend 10. Effectively I'm just spending 10 more. I needed this product later on, I'll just buy it right now. but it's all about timely response. So in order to do all these calculations in near real time, you need that computing power, that compute engine to do all these calculations in a fast and a timely manner. You can do it in Databricks, you can do it in Snowflake, or you can, have your own cluster on which you can install Anaconda, Python, and you can do it yourself. You don't have to have it, but a lot of large organizations will typically either or Snowflake, or they'll use on cloud data warehousing. BigQuery is getting more and more popular. A lot of my customers, they use BigQuery as well. So data warehousing is one use case uh, where you're using notebooks. You can visualize that data now. So that's why Brother Prashant is covering data visualization. Or you can use a reporting tool like Power BI, Tableau to do the reporting. You can expose that data as a data hub and sell that data. So there's something called as data monetization, where like what Nielsen does, it's selling your data and to other customers. You can sell your data, you can provide API interfaces, you can search on that data, you can have downstream applications consuming that data as well. So you are doing all those calculations to be able to do that, uh, to maximize the value of your data. And then this could be on prem, but typically the trend is to do it on the cloud. You want to make sure you're governing the data using data catalogs. Governance of data is, what is this data, who accessed it, when did they access it, what does this data mean, what is a data dictionary, and you've got a deployment process to do it. So if I were to map products, so you've got social media data, Facebook, Twitter, so on. You could be using Talend, or you could be using Airflow, you could use Click as your change data capture, Kafka as your messaging. You put it on Azure Blob or Azure Blob configured as Data Lake Gen 2. You store that data in a .delta file or a .parquet file or a .csv as well. But Parquet and Delta Lake are the most preferred format to store the data. So when you're doing data analysis, if someone says, I've stored Parquet files on Data Lake, go and grab it and analyze the data, you'll know that data, that Parquet file or a .delta lake file or a .parquet file is nothing but a file like a .csv file. You can easily read them using pandas and do your rest of the analysis. How and where that Parquet file came in, you kind of know the history. So this data pipeline on how to bring the data from the line of business source to this data lake, that's a data pipeline. If you're using Python to bring that data pipeline, that's data engineering. So that's how you get this data. You can use Snowflake for data warehousing. You can use Databricks. You can use notebooks to execute your in that data. You could use Power BI or Tableau or any other looker or any other tool that you want, Sisense and so on. You can expose that data as a data hub through an API gateway like Azure API Management Gateway, or we call it as APIM, or AWS API Gateway, or in Google, you can use Apigee. These are just different product names. If you just remember those product names, they'll just show that you know what the landscape looks like, and you can use this data behind the scenes. I'll take a pause over here. This covers the big picture, so you know what you're analyzing, how and where those calculations are being done. Why data lake is relevant? Because realistically, 95% of the time you will be bringing that data from a data lake to do that analysis. And we use the word raw zone, raw data as it is, as it comes from the transactional system. You can join that data in a notebook and then visualize it either using Power BI, or you can visualize it within the notebook, as Brother Prashant has shown in the past. Any questions?
Dr. Mukesh, sorry, but I have a few questions. If nobody, yeah. Um, so we talked about. I have multiple things in the mind. I'll just try to phrase them. So one thing we discussed about is the Nielsen platform, wherein we can get the competitors' data. I just have one question in my mind that how can we relate it to the data privacy? So suppose I need some data of some competitor and I try to get it from Nielsen. So I don't know about the data privacy policies which Nielsen follows, but I as a means user of that data, won't I
Yeah.
be doing the data breach kind of thing? Yeah.
Yeah. Very, very good question. So, as you know, India recently passed, I think in August, just last month, they passed in a Data Regulation Act of 2023. Data privacy is important throughout the world. So in US, in EU, they have a data privacy law called GDPR, and the Indian Act was modeled based on GDPR. GDPR is the most stringent data privacy act, and it has the feature called right to forget, right? And you cannot use my data without my consent. There was no such law until last month, but now India played catch up and introduced that. What that means is that if you don't give your consent, then the organization cannot use your data. Now, keep in mind, they cannot use your data, which ties that data back to you. So I made a application, I consented. Usually, now what you'll start seeing is whenever you sign up, there will be a legal verbiage which will say, I am giving consent. If you don't give the consent, you cannot even sign up. So
Right.
they are going to force you now to get your consent so that they can sell this data. That's one way. Good organizations, ethical organizations will give you the option of saying, yes, I'm still going to use your portal, but I'm not consenting of selling that data to third party sources, right? Because without that consent, legally now they cannot sell that data. Yeah. However, there's a trick. Uh, they can sell your data without your information in it. So they can still sell your data without your consent as long as it doesn't have any PII, personal identifiable information in it. So when I'm submitting for my mortgage application, I'm putting in my income, my employer name, I'm putting my first name, last name, my address, all the details. All of that is personal identifiable information because it identifies who am I, where am I staying, who's my employer, what is my salary, and so on. So you have to de-identify that data. You remove those attributes which can be traced back that record saying this record belongs to this individual, right? Then you can sell that data. So if I remove or instead of saying, this is my first name, last name, I just put 123, or I obfuscate the data. I pseudo anonymize it. Instead of your real name, first name, I put just some fictitious name. Instead of your age being 45, I put 43 or 48. So it's a similar age group, but not the exact age. I'm not putting date of birth, but I'm just putting the age as of today. So I can still sell the data as that individual data cannot be traced back to the individual. Now that can be very challenging as well. So you have to make sure there's no data leakage at all. Because in US, right, there's a very good well-known case published on the internet. You can read it. Brad Pitt took a taxi from New York, one of the streets in New York, and paid in cash, thinking that no one can trace that back, and identified him that such a big film star would take a taxi and pay in cash. Why he paid in cash? He didn't want to use a credit card, because if he pays in credit card, then you can tie it back as well. Yet they were able to identify that specific record, which so the New York taxi record was published on the internet. Someone did the data analysis and said this particular taxi ride was done by Brad Pitt. How did they know that? That data source by itself didn't have any information. It had no mention of Brad Pitt, but they traced back where he attended that event, and they had access to some of the surveillance cameras, and they were able to trace back using face recognition that this was that specific person. So when we are doing data analysis, or we are de-identifying the data, we need to absolutely be sure that you're not giving any data attributes which makes it possible probabilistically to be able to tie that information back to an individual. Many times what organizations do, they will do what's called as tokenization. There are products in the market like DataVand. We use, and there are a lot of other products. So you'll see in the security, there's HashiCorp Vault. With HashiCorp is a company. They used to be open source. Now they went public. What is their product? You can tokenize your data. What is token? In the old days, when you go to the post office or you go to the bank, instead of standing in a line and saying, I am 10th in the line, you go to the line, you pick a token, which is a number. And the token is nothing but your number, your queue in the line. So you have the information. Your information is your 10th in the line. But instead of saying 10th in the line, you just have a number. You can exchange that number, give that token to anyone else as well. So you're tokenizing, or you're kind of encrypting that information, which is not easily understandable. So instead of taking your first name, last name, and all those details, you replace it with this token string. If that token string is nothing but a hash value, so corresponding to that first name, last name, all those attributes, you get the token string. You sell the data using that hash value. No one knows what that hash value is. What does it translate back to the user? But another credit card company, if it uses that same tokenization software, the way the hash function works is if you give the same input, it will create exactly the same output. That's what a hash function does. If I put number 1, 2, 3, 4 and 4, 5, 6 as 2 inputs, it will create this string, but that string will be exactly the same if the inputs are same. Even if there's a space difference or one thing, small thing change, the hash value will be different. So they take your first name, last name details. They use tokenization software. They sell the data with the token value in it. I can buy that data from one company with that token value. I can buy data another from a totally different company which has that token value. If they use the same software to tokenize it, now I can join that data based on that token value. And I know it is for that same person. I don't know who that person is, but I know it is that same person who did this shopping using this credit card one. It's the same person who did this shopping using credit card two. I don't know who the person is, but the token value will match if it's the same person. That way, I can join all this data. I don't know who the individual is, but I can still sell it. That's what Nielsen does. That's what a lot of other organizations do. That's how they do all this data analytics and data analysis to use the information that you provided without consent or with consent. Did I answer your question?
Yeah, thank you so much, Dr. Mukesh. Quite, it's like means new insights actually in terms of data privacy. Yeah, sure.
Yeah.
Yeah.
Okay. Any other questions? Otherwise, we'll see if Sister Raki can share with us a mind empowerment technique.
One more question, Dr. Mukesh, if you allow me
Yes.
to ask. Yeah,
Sure.
so this data architecture, definitely we will need to go through the recording once again to make more sense out of it. So it's the first slide where you give a kind of general picture, and the second slide you have given the names of tools as well in that specific section like produce, organize, analyze, and consume. And when I was listening to the last recording, you talked about data science platforms. So, I mean, all these things and having the knowledge of all these things, digesting them and then getting into the data analysis, it may be a overwhelming thing or it may take some amount of time. But that data science platforms, if I understand it correctly, and please correct me, that data science platform will make it easy for us to just kind of get all these things done through that platform only through some tools. That's something I'm just trying to understand.
Yeah, yes and no. The key capability of the data science platform is that it's instead of you writing all these predictive algorithms, and one of the sessions we covered, right? There's linear regression, there's deep learning, there are a lot of different algorithms. Instead of you writing those algorithms, you can do drag and drop. So you can do self-service AI, where you don't have to do a lot of coding. You can just drag and drop and create these AI ML pipelines. So it allows you to make it faster to do this data analysis. Now, there are some products in the market So example of data science workbench is Data IQ, most popular. There are others like Domo as well. Uh, but essentially what you're doing is you're still using the data on the data lake. You're connecting to the data lake as a data source. You're still using the algorithm. You're visualizing within the tool. There's a new concept in data architecture called data mesh. There's a product called Starburst. With Starburst, what Starburst and what the concept of data mesh is that not all organizations have brought all the data to the data lake. That's what they want to do, but it takes time. They need to have the budget to, not all companies have CDC capabilities. So it takes time. So what it says is, you want to analyze the data, but you don't have all the data on a data lake. You have only a small percentage of the data in the data lake. So use a tool like Starburst or use data virtualization tool in which you're virtualizing your data source. So you're thinking, oh, all my data is one place, but actually it's not. You have these data source connectors. You're virtualizing the data, you're modeling the data, and you're doing the analytics within that platform to be able to do the analytics, whether it's descriptive or predictive. So there are more and more tools coming in the market which allow you to, which don't limit that your data should be in the data lake. You can pull your data from the transactional system. But the whole reason why we started this journey of data lake was that you want to make sure your transactional system is not impacted. So if you're virtualizing it, that problem still remains. If you're going to bring in heavy loads, large volumes of data, that problem still persists. So yes, you can do data virtualization. You can use Starbust. You can use these virtual data sources. You can use Alteryx as another data discovery tool, but you're still putting load on the transactional system, which can have impact on your performance system. So that's a limitation.
Thank you, Dr. Mukesh. And the last thing is about this last two rows about infrastructure, governance, security, and DevOps. This is like the infrastructure which supports all the things that we discussed. Is that the case?
Yes. So if you have it on prem, then most of the time you should know what are containers and what is Kubernetes. That's a separate topic by itself, but I'm just throwing out these words so you know what all you need to know to be able to get a high paying IT job. Our purpose of training is not for you to get a job. Our purpose for you to not just be a data analyst. We want you to be the best data analyst. We don't want you to get a job. We want you to get the best job. In order to get to be the best in your field, having little bit knowledge. You don't need to be an expert in containers. You don't need to be an expert in Kafka, but little bit of everything. You need to know a little bit about Kubernetes. You need to know what are containers, why containers versus virtual machines, what is serverless computing. We've covered upon this in some of our other trainings, but it's always good to know why should I use containers, what are containers, and so on. So infrastructure is nothing but that hardware infrastructure, that physical infrastructure, which is the backend for the data storage. So data lake, where is that data stored? Stored in object storage, it's on cloud. But if it's on-prem, then you need to have your own server on which you store that data. What kind of server it is, and so on. So that also is infrastructure. Then how are you governing the data? Do you have a data catalog like Colibra or AWS data catalog? Do you have a data vault where you're storing all the keys, so you're securely transmitting and communicating all this information? Nowadays, instead of DevSecOps, what's even more relevant, I should update on this slide, is data ops. How are you deploying these data pipelines across these different systems? So just a little bit about what is data ops, what is data catalog, what is data governance. That would definitely help you stand out, because not every data analyst would know about it or even heard about it, but you are the best data analyst. So little bit about everything is always good. Any questions? We are here to serve you. So you can just ask, say, we need a session on this topic, we'll cover it.
That's so great. Thank you so much, Dr. Mukesh. Thank you.
Any other questions? I think there were some chat questions. Let me make sure I answered those. Is trading apps or web servers which APIs? Yes. So there's something called as a web socket as well, where they're just publishing that information. So in a REST API, you have to request, you get a response. But if you're just publishing, broadcasting information, then instead of an API, it's we use what's called as a web socket. So you're just publishing information onto it. So stock widget, you'll see it's just dumping information. Behind the scene, it's using a web socket. That's how it's getting the information. Okay. Let's see, is Sister Raki there? Otherwise, we can share a mind relaxation technique. Okay. Seems like she won't be able to join. So I'll cover a mind relaxation or a mind empowerment technique. In one of the sessions, we discussed how does the mind work. You know, the mind is a very powerful tool. You know, whenever we buy an appliance in the market, right? You're buying a washing machine or a hi-fi gadget. It comes with a manual. You know, washing machine comes with a manual. There's a car manual and so on. The mind, the human mind, is a very sophisticated, highly functional, does amazing things. Yet we don't know how to use it because we don't get a manual with it. We don't have a mind manual or a life manual. Because of a lack of that manual, we tend to look upon religions as that manual and derive those rules as to how to live our life. Yet we fumble. Religions have existed for 2,500 years. Yet they've failed to achieve the simple objective on how to be peaceful and happy. Think about it. 2,500 years, multiple religions came with the single most objective for humans to be peaceful and happy. Christianity came to 2,000 years back. Before that, there were other religions, yet they all failed in the single objective, how to be peaceful and happy. They tried to come up with that manual, but those manuals were so restrictive and they didn't evolve over a period of time, and they didn't achieve that objective. We in our meditation, we understand the mind because our teacher is supreme teacher. He's given us that manual on how to be happy, not one day, not one month, but how to be happy every moment of our life. Now, that's a big, complicated thing. No one has achieved it. None of the religions have achieved it. How to be happy all the time, no matter what the situation, no matter what type of boss you have, no matter what your boss says to you, no matter what the economy is doing, no matter what is happening around you, how to be happy all the time. That has been the pursuit of humanity and mankind for thousands of years. Yet we did not achieve. Religion was there to achieve that purpose of establishing peace and happiness, yet religion ended up creating wars. Look at all the religions, no exceptions. However, now we know the operating manual for our life. How the mind works is the key to understanding and using that manual. So that's the reason we give so much emphasis on understanding the human mind, because the mind has amazing power. If that power, when not utilized properly, can do a lot more damage as well. It's just like fire. If you regulate that fire, you can cook food with it. If you don't regulate it, it can burn down the house. So is the power of the mind. It can do a lot of creative, constructive things. But if you don't know how to use the mind properly, it can do a lot of destructive things as well. Understanding each individual, your mind, how you think, how you perform, is the key to understanding humanity, is the key to understand the future of mankind. because you cannot change the world. Mahatma Gandhi once said, I tried to set out to change the world. I tried changing my country, I failed. I tried changing my city, I failed. I tried changing my locality. He tried this while he was in South Africa. He failed. He then realized the change needs to begin with ourselves. He said, I changed myself. The change in me inspired others around me in my locality to change. The change in that locality inspired the people in my region to change, and that change inspired my country to change. And that was one of the factors that brought change in the society, which still serves as an inspiration. So we cannot change others. We cannot change our boss. We cannot change the mentality of anyone. We don't have the power to change it, but we have full 100% power to change how we think, to change our attitude, to change how we respond to events. We cannot change the circumstances, but we can always change how we respond to it. We have the power to know how to respond to it. If someone says something to me, they might say all the wrong things. They might be angry at me. They may not be polite. They might things which were not respectful. The option is always mine how I respond. They might trigger the response in me, but what is the response defines who I am. The mind is defining and taking those discussions. My soul is making that decision maker. I am the decision maker each and every moment of what I need to do. People might be instigating me, circumstances may want to stimulate me to do something, but every moment I am the decision maker. Accepting this fact is the first step to mind control, where you're not controlling mind of others, but you are in full control of yourself. Because once you're full control of yourself, you can achieve that state where you're constantly happy. Because what's not making you happy are these external circumstances and your own habits, your past experiences, those memories, your old habits of constantly being negative or saying this doesn't work or this person, these impressions that we have other people, and how we respond to circumstances and events is what's making us unhappy. If we know how to respond to those events, then happiness is a natural state. Love is a natural state. Peace is a natural state of the soul. Why does everyone want to be happy? Why does everyone want to be loved? Why does everyone want to be peaceful and experience peace? Because that's all natural to us. We don't have to do anything what is natural to us. We are naturally happy. We are naturally peaceful. We are naturally loving. Now you'll say that doesn't make sense. Take an example of a newborn child, right? Most of them, I wouldn't say all, but you'll see the newborn child, it's naturally loving. It's not making any judgment. This person is bad. This person is not bad. Whoever holds that child experiences love. When you hold the child, you automatically smile. The child didn't do anything. It brought you into that natural state. It made you realize and you felt in that natural state of being peaceful, happy, and loved. That's an indicator, that's a proof by itself that happiness, peace, and love is a natural state. When we are not in that natural state, we do anything, everything to be in that natural state. We want to be loved because being loved is our natural state. We want to be happy all the time because happiness is our natural state. So the question is how to be in that natural state all the time. A simple way to describe it is the moment we are soul conscious, we are in that natural state. The moment we are in body conscious, we are within the limits of the body. And the root causes of taking that natural state away from us is body consciousness. With body consciousness come the five vices, the most prominent being ego. I did this. I got this job. I succeeded this. I made this much money. I built this house. I bought this car. This I limits you into what is the duration of this body. That duration, that limitness of this body brings in fear, anxiety as well, because the body has limited time duration. The soul is immortal. It's not living for that limited time duration of the body. Yes, you bought that house, but who gave you the intelligence to do that house? You'll say, I worked hard for it. Yes, you worked hard for it, but who was empowering you and giving you that capability of the mind? Why is it that one person remembers more, one person remembers less? You'll say, well, my brain is like that. Why is your brain just like that? When God created, He created everything equal. When He gives the supreme knowledge, He gives everything equal. Just the same way, when a teacher is explaining in the class, the teacher is not giving any partial extra lessons to the students. He's explaining the same way in the class, yet some of the students, they score 100%, some score only 10%, some score 40%. It is up to the student how we utilize that knowledge. Same way, how we use this knowledge results in some being smart, some being less smart, some being very smart. But what is the source of all this knowledge? It's the supreme intelligence. We call it as the Supreme Father. Some call it as Godfather. Some call it as Allah. But it's that point of light, which is the ocean of knowledge, which is the ocean of love, which is the ocean of peace. So when we pray to God and we ask to God, we we get more of that peace and knowledge and love. If you ask God, I want a Mercedes Benz car, and you pray for it, you're not going to get it, because God says, I don't manufacture Benz or BMW. I don't sell that. You are asking someone for something, he doesn't have that. What God has is your natural attributes: love, peace, ocean, ocean of love, ocean of peace, ocean of knowledge. You ask for strength, you ask for courage, He will give you that. You ask for a car, it doesn't even get to him, right? Because he's not tuned to this frequency of I want these materialistic things. It doesn't even get to him. In some session, we'll cover how does our communication reach to God. Does God understand all the thousands languages in this world? Someone is speaking Marathi, someone is doing English, someone is doing some African language. How does God communicate? Does he understand all the languages? No, he doesn't, right? What goes to God are these pure vibrations. Each thought that you have, if it's a pure thought, it has that power to reach to God. But if it's a materialistic thought, I want this, I want that, it doesn't even reach to God. So you're just wasting time. What you want from God is, you want this strength, you want this peace, you want happiness. God says, I have an abundance. Get as much as you want, but at least know what you want to, what are you asking for, that I have, that you can get as much as you want, because I am your Supreme Father. We have our parents who gave us birth. All that, we say is, we say God is truth. We will say, I have my parents. How is God my Supreme Father? We say God is truth. How is that relevant? I have parents in this life. When I die, my soul leaves this body, takes another body. I'll have a different set of parents. I'll again leave that body and I'll take another body. I'll have a different set of parents. The name of my parents is changing. So if I look in the infinite span of time, who are my parents? Well, it depends which body I was. But there's one parent which is all the time, that is constant, does not change with time. And that relationship of the soul with the Supreme Soul is sort of a parent and child. Which parent wouldn't want their children to succeed and be happy and peaceful all the time? Every parent would want their children to be happy and successful and be as powerful as the parent itself. So does God. God wants every child on this world to be happy, peaceful, prosperous. But we don't know how to connect to God. We don't understand how to use the mind. We don't have that operating manual of life, and as a result, we keep searching, and we don't know how to use this powerful mind, and we feel sorrow and distress. So the key to that is understand the mind, and the soul is nothing but it has three departments: mind, intellect, habits, or sanskars. Everything that happens in the mind is a thought. It starts with a thought. You see something, creates a thought. You remember something, it creates a thought. We practiced this last time. Create a happy memory. Instantly, you are happy. The state of the mind is directly proportional to the quality and that thought. You create a godly thought that I want to help others. Instantly, a different energy fills you up because that thought is not just for you, it is for others. It has that energy and the power to take you and do things that you thought you wouldn't be able to do it. Try it out. I might say all these things, but it is for you to try it. The one who tries it will benefits it, right? So the mind, it starts with a thought, then is the intellect, which is the judge. It makes that decision. Your boss said angry words to you, it creates the thought, who is he to tell me? I'm going to respond back. This, it's, you feel hurt, you get those thoughts. But the decision maker is the intellect. Your mind will take the decision saying, that that soul, that boss, maybe he's a frustrating day. He's not meeting his goals. He's got things to do. But that has nothing to do with you. It's okay for him to criticize, but you know you did the right thing. So you have to forgive him and say it's okay. You know, he's frustrated with all of you. He's frustrated with all his employees, or even if he's just frustrated with you, because even if you didn't do wrong, it's okay, forgive him. The one who forgives is more powerful than the one who responds in that situations. Just forgive him. So in this example, you took the higher ground and you forgive him silently. You don't have to say it in words that I forgive you. Boss won't like it either. You're just saying it in words. I forgive you. What is the outcome? You are going to be peaceful. This person will keep talking, blah, 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 blah. You listen it. Someone is throwing garbage, is giving you garbage. You throw garbage out. Don't keep within you. Boss is going to say all these things. It's okay. You are more powerful than your boss at that moment. You just give him forgiveness and you move on as if nothing happened. Try it out. It takes a lot of patience and courage to do it. It takes a lot of practice. It doesn't happen in one day where someone is telling you things and you listen for 2 minutes, 5 minutes, 6 minutes, you'll be like, okay, now I'm going to talk for 10 minutes. The human mind is just accustomed to it. You just got used to it. But if you want to be that change bearer, if you want society to change, you want the country to change, you want the world to change, that change starts with you. That change starts from you today itself. Don't wait till tomorrow. When Ramayana ended, Lakshman went to Ravan. Ram said to Lakshman, go to Ravan and ask him, what is the most important lesson of your life? Because Ravan was a Shiv Bhakt, right? He was a devotee of Lord Shiva and he had a lot of knowledge. So Lakshman went to Ravan and said, of all the things that have happened in your life, what is the lesson for me? What can I learn from your life? And Ravan said one thing. He said, whenever you want to do good things, do it right there, right that moment itself. Whenever you want to do things that are unholy, you want to do bad things, leave it for tomorrow. Because tomorrow something else will happen and you'll probably forget. But good things, don't leave it till tomorrow, because if you leave it till tomorrow, then again, few things will come up and you'll forget. The mind is very forgetful. So you have to constantly remind yourself, you have to constantly remember who you are. You are not the body. You are not your first name and last name. You are not who you think you are. You are a powerful, very highly capable, immortal soul. God is truth. What is definition of truth? Truth is something that does not change with time. If I go in the court and I say something today and then tomorrow I say something, will the judge believe me? No, because I changed my statement from yesterday. What I said changed with time. It's no longer credible and we'll say that is false. You're no longer speaking the truth because what you said yesterday and today doesn't match. What is the ultimate truth of life? Our parents in this life wouldn't be these parents in the next life. So, what is the truth in life? If things are changing from one birth to the other, everything is changing. Our wife, our children, our parents, our house, our location, nothing is constant. There's only one thing constant in this entire journey of the soul, because everything else is false. Truth is something that does not change over the period of time. If you expand that time horizon beyond the period of this life, if you expand the time horizon across the multiple births that you've taken, what is the truth? There's only one truth. That one truth is the relationship of the soul with the Supreme Soul. That relationship of a parent and a child, that we are the child of that Supreme Father. We are the child of that Allah. We are the child of that Godfather. We are the child of that Shiv. That relationship is the only constant thing. Everything else changes with time. Your partners, your friends, your parents, your jobs, everything changes with time. If you keep that perspective, who is your true friend? If you build all those relationships with the Supreme Father, you will have abundance of everything because you are connected with that supreme ocean of love, ocean of happiness, ocean of peace. You will have everything that you ever desire and need because every parent would want their children to succeed and make sure they've got enough of everything. You already have it. You don't have to do anything. You just need to be able to tune your mind to connect with the Supreme Father and be able to realize the tremendous potential already within you. You don't have to go through all these places of worship begging, saying, give me peace and happiness. You've already tried that, yet where you are. Experience it yourself, right? Would a father or a mother or a parent want their children to beg and say, please give me peace and happiness? No father, no parent would ever want that. So says the Supreme Father that I didn't create you to become beggars. I created you to be emperors. I created you to, to spread the knowledge of love and peace and happiness. That is the power that I gave you. So use it. So with that, I'll stop our session for today for you to think about the powers that you have, the power to love, the power to forgive, the power to grow, the power to be at peace, all these powers. For those who are more interested, we can talk more about it, or we do Raj Yoga sessions where we teach about how to control the mind in a very systematic methodological manner. But we'll try sharing those techniques in these 10 minutes, 15 minutes, as and when that opportunity arises. Thank you very much, all of you. Someone had a question? You had raised a hand? Not. Have a great weekend. Thank you, all of you, for participating.